Welcome back. So as promised in the last video, we are going to solve some problems on integration. Okay, so now I will show you how to do the simplification by using the formulas, and I'm not covering all the questions, but most of them I'm covering are important ones, and you will get the idea to solve the other problems as well. Okay, so let's start. So here you can see we have expansion, right? A minus b the whole square. So we know the formula. It's a square minus 2ab plus b square. Simple, right? So we need to multiply this, right? So x square multiply by 1 minus 4 upon x plus 4 upon x square into dx, right? So if you open the bracket, it's x square. Now here you will get minus 4x because x square and x will get cut. Then x square got cut, we'll get 4, right? We know the remaining steps of integration. This we have done the simplification. Now we have to solve the integration, right? It's basically x raised to n. So first we'll get x cube upon 3, right? Minus 4 is constant. We'll get here x square upon 2, and here x raised to 0 will become x raised to 1 upon 1 plus c. This is important, you need to remember, right? So this is our answer. Simple, it's not that difficult, right? Let's move to the next question. It's again a simple thing, but you just need to divide whole the stuff. So 3x cube divided by x root of x minus 2x divided by x root of x plus 5 divided by x root of x dx. So I hope you all know x root of x means x raised to 3 by 2. If you don't know, I'll show you. It's not that difficult. X is x raised to 1 and root of x is x raised to half. So by using rules of indices, we will get x raised to 1 plus 1 upon 2. We'll get x raised to 3 by 2. It's not that difficult, right? It's simple. Now you need to again use the rules of indices, right? So here we have x in the whole term. From the top we have x cube, so x raised to 3, and bottom it's 3 to the 2, and it's in the division. Though by rules of indices we'll get 3x to the power of 3 minus 3 by 2. Same here, minus 2, x raised to 1 minus 3 by 2, and here we have plus 5 x raised to minus 3 by 2 dx. Again you need to simplify, right? So 3 minus 3 by 2 is 6 minus 3 by 2, 3 divided by 2, so it will give you again 3 by 2 minus 2. X raised to 1 minus 3 by 2 will give you x raised to 2 minus 3 by 2, so that will be x raised to minus 1 by 2 plus 5 times x raised to minus 3 by 2 dx. Now you need to solve integration. It's simple again. So 3 you have x raised to 3 by 2 plus 1 by 2 is x raised to 5 by 2 divided by 5 by 2 minus here x raised to minus 1 by 2 plus 1 will give you plus 1 by 2 divided by 1 by 2 right, plus 5 times x raised to minus 3 by 2 plus 1. So it will give you minus 3 plus 2, that is minus 1 by 2 divided by minus 1 by 2. Simple. It's that simple. It's not difficult. I hope it's clear to everyone, right? Now you can do the further simplification, or else if you keep this much, that's also fine. Okay, so like this you have to solve the integration. Okay, and we have used all the relevant formulas here, right? So let's move to the trigonometric questions. Now I don't know, people feel this difficult, but it's actually not. You can see I will try to solve every question. It's just a simplification. Okay, everything else is you can integrate using the formulas, but the part that is difficult is integration, and it is not also difficult. You know all the formulas, so let's move. Okay, so we know tan square x, so we all know the identity, right? 1 plus tan square x is sec square x, right? So tan square x can be written as sec square x minus 1 dx, right? And we all know the integration of sec square x, and we all know the integration of 1. So if you solve this, you will get the value, which is tan x minus x plus c. Plus c is important. Here I forgot to write. Okay, so it's simple, it's not difficult, right? The next question, you can see sine 2x. We remember the formula. It's 2 sine x times cos x divided by cos x dx. It will get cut. 2 is a constant value, and it remain with sine x dx. So you know the integration of sine x, it's minus cos x, so overall it will be minus 2 cos x plus c. Further on, I'll just show you the simplification. You all know the integration formula, so you can solve it easily. Okay, that's not a problem for you. Okay, so now again, what is the important part? You need to simplify the question, right? So how you will simplify this? So you can see here, we can just simply what I have done, I have just separated the square term into multiplication as a cos into cos. Okay, and now you can see it's sin upon cos is tan x, and 1 upon cos is sec x, and we have the integration value of this term, right? It's sec x, and you need to write plus, right? It's simple, it's not difficult. Let's move to the next one. It's cos 2x divided by sine square x. Now I hope you all remember the formula for cos 2x in terms of sine. Why I am taking in terms of sine? So we will see cos 2x can be written as 1 minus 2 sine square x, and in the denominator we have sine square x. Now if you separate the denominator, you can see what you will get, 1 upon sine square x minus 2 integration of sine square x divided by sine square x, which is simply get equal to 1, right? 1 upon sine square x is cosec square x minus 2 integration of 1 dx. Now you can simply solve this, right? You know the value of integration of cosec square x is cot x, and integration of 1 is x, and don't forget to write the c term. Okay, it's simple, right? So it's not that difficult. You just need to simplify the equation as per your convenience, and you will get to the answers. Okay, again we have cos 2x. Now here what we can do, we have three formulas for cos 2x, right? 2 sines 1 minus 2 sine square x, cos 2 cos square x minus 1, and the last one is sine square cos square x minus sine square x. So you can just look at the problem, and you can see if we take this one, cos square x and sine square x, and as you can see in the denominator we have both of the terms, right? So if you separate the denominator for each of the numerator, one of the terms get easily cancelled, right? So you can see it's simple. I hope handwriting is clear. It's not that good. Okay, cos square x got cut, sine square x got cut. So what are you remaining with? 1 upon sine square x, which is cosec, and 1 upon cos square x is sec square x, right? You know the integration for both of these terms, which is simply minus cot x, and for sec square x it is tan x plus c. This you should remember, right? So it's simple. Next one. Now As you can see, for this particular question, we don't have any formula that is directly giving us this thing, right? So what we can do, we can rationalize. So 1 plus sine x, we can multiply numerator by 1 minus sine x as well as denominator by 1 minus sine x. So we are not making any changes. So you can see sine x into 1 is sine x minus sine x into sine x will give you sine square x, right? And denominator, you can see a plus b, a minus b will give you a square minus b square, right? So we have sine x up minus sine square x, the whole thing divided by 1 minus sine square x. Now you know the identity, sine square x plus cos square x is 1. So 1 minus sine square x will give you cos square x. Simple. You just need to remember the identities and that's all. You can solve it very easily, right? So what are you left with? So if you separate the denominator, you have sin x upon cos square x minus, here you have sin square x upon cos square x. First term, I think you have seen this term here in the third question, and you can again similarly simplify and solve it. You will get the integration for the first term as like integration of tan x into sec x. So I don't need to repeat it because it's already done. And here you can see sin square x upon cos square x will give you tan square x. This also we have done the first question, right? Tan square x. So you can simply write down the integration value. So tan x, sec x tan x is the integration of sec x, right? Minus, and tan square x was the integration of tan x minus x. If you simplify this again, you can simply do it. Tan square x can be written as sec square x minus 1, and again integration will give you minus of tan x plus x plus c. So it's just simplification that you need to do, and everything else is really simple. It's not difficult. Okay, so let's move to the next question. Okay, again here we don't have any formula for direct this thing, but we can simplify it again, right? So we can use again the rationalization. So if you multiply with sec x minus tan x in the numerator as well as in the denominator, so what you will left with, so first term will be tan x multiplied with sec x minus second term will be tan square x, right? And again a plus b into a minus b will give you a square minus b square. Again we know this identity, 1 plus tan square x is sec square x, so it can be rearranged as sec square x minus tan square x, which is equal to 1, right? So I hope till now you all are familiar with these terms, right? And in the numerator again we can see it's the similar kind of question which we have solved here, right? Look at this. So from this we can significantly say that it's just a simplification that you need to know. Everything else you can do, right? So again it will give as it's the same kind of question, this one and oh, it's not working. Yeah, this one and this one, you will get the same answer, right? So sec x minus tan x plus x plus c. Simple. Okay, now this one. Okay, now this is again a kind of question that could get repeated. Okay, it's the simple again you need to do the simplification. Look at this. So 1, I'll keep it as 1, and we know sine 2x can be written as 2 times of sine x cos x times of dx, right? Okay, now 1, we know the identity, it's sine square x plus cos square x plus 2 sine x cos x dx. Now you can see the expression, it's like a square plus 2ab plus b square, right? So it's just the expansion of a plus b the whole square, right? Square and square root will get cancelled, you will remain with sin x plus cos x dx, and we know the integration of sine is minus cos x and integration cos of x is sin x, and the remaining term is plus c. So it's simple, it's really simple. You can easily solve this kind of questions. Just you need to remember the formulas that I have given, okay, and that's it. Integration is no more difficult. Again, you need to do the simplification. So now we can use we have two terms, right? 1 minus cos 2x. Cos 2x, again we have three formulas, but I'll use that formula which will make the question simpler. Okay, so if I use the formula which is related to sine, it's 2 sine square x minus 1, right? Oh, I forgot the formula. Yeah, here it's 1 minus 2 sine square x, right? So 1 minus 2 sine square x to dx, open the brackets. So what you will remain with, 1 minus 1 minus minus will become plus 2 sine square x dx, plus 1 minus 1 get cancelled, you will remain with square root of 2 sine square x to dx, right? Square and square root will go and you will remain with root 2 of sine x. And you know the integration of sine, it's minus cos plus. So it's simple, it's pretty simple and pretty evident. You can solve it very easily. Now let's move to the last question. It's sine 4x times cos 3x dx. Now it looks like sine a times cos b, and if you remember, it's the product formula. So it was something like this. I hope you remember this formula. Here it was sine a plus b plus sine a minus b, right? So we need to use it. So it's half integration of sine of 4x plus 3x plus sine of 4x minus 3x dx, and you will remain with sine of 7x plus sine of x dx. We know the integration, it's cos 7x, it's minus cos x plus c. So like that you can solve easily the integration. Okay, in the next part I will solve the further problems. Thank you so much for the attention. See you.